In this video, we're going to talk about adding and subtracting fractions with unlike denominators. In the past, you have learned how to add and subtract fractions when the denominators were the same. So an example might have been 1/4 plus 2/4. And in order to have done this, you looked at the denominators. They were the same, so the denominators stayed the same in the answer. And then 1 plus 2 was 3. And this was the same situation with subtracting. Let's say we had 7/8 minus 2/8. The denominators were the same, so we put down the 8. It remains the same. And then 7 minus 2 was 5 for 5/8. This was an easy process as long as the denominators were the same. But now we're going to look at some problems where the denominator is not the same. We call these unlike denominators. Alright, let's say we have this problem, 2/5 plus 1/7. Well, the first thing I would want to do is to look at my denominators, and I notice they are not the same. So that tells me I've got to use LCD. LCD is the process of writing down the multiples until I see a multiple that's the same. So I'm going to start with my 5s, and I have 5, 10, 15, 20, 25, 30, and then my 7 is 7, 14, 21, 28, 35, 42. Well, I don't see anything common yet, so I'm going to continue the 5. And I go on to 35, and right there I tell myself, oh look, I see two that are exactly the same. I see a 35 here, and I see a 35 here. So that is my LCD. My LCD would be 35. Well, then what am I going to do with this LCD? If you remember back, I have to turn each one of those fractions into something 35ths, and that's where equivalent fractions come back into play. All of these things that we've learned about fractions all come back together in different concepts. So I'm going to turn the 2/5 into 35ths, and I'm also going to turn my 1/7 into 35ths. I have to think to myself, 5 times what is 35? And I say, oh, 5 times 7. So 2 times 7 would be 14. Then I say 7 times what is 35? 7 times 5 is 35. So 1 times 5 would be 5. So now, if you notice, I have denominators that are exactly the same. So now I can do the addition. So instead of using 2/5 plus 1/7, I'm going to say 14 35ths plus 5 35ths equals, now 35 and 35 are both my denominators, so it stays the same. And then 14 plus 5 is 19. If I could reduce it, I would reduce it. But if I can't, just leave it at it as is. So 2/5 plus 1/7 equals 19 35ths. If you had just seen this problem with that answer, you would have been thinking, how in the world did that happen? Well, it happened through the process of LCD. Let's do one more example, but now we're going to do a subtraction problem. 3/4 minus 1/3. First thing I look at, I see, oh, it's fourths and thirds. I cannot combine those or subtract those if I don't have a common denominator. Right now they're unlike denominators. So I'm going to do my multiples. 3, 6, 9, 12, 15, 4, 8, 12. I'm going to stop because I already see my common one. I've got 12 and 12. So my LCD is 12. Now what do I have to do with that LCD? I have to get an equivalent fraction for each of those. So I'm going to turn 3/4 into 12ths. And I'm going to turn 1/3 into 12ths. 4 times what is 12? Times 3. So 3 times 3 is 9. Because remember, whatever you do to the denominator, you must do the exact same thing to the denominator when you're adding and subtracting. 3 times what is 12? 3 times 4. So 1 times 4 is 4. So now I really have 9/12 minus 4/12. Because they're the same denominator, the denominator just goes over there. Don't have to worry about changing it now. 9 minus 4 is 5. and 5/12 cannot be reduced, so my answer is 5/12.